What's up guys, welcome to my YouTube channel. In this video we're going to build a transistor motor driver on breadboard. These are the components which you need for this experiment: a breadboard, 9V battery, a DC motor, BC547 NPN transistor, a push button switch, 1 kilo ohm resistor, and some jumper wires. I'm gonna start by connecting my BC547 transistor to the breadboard. I'm going to connect the emitter of the transistor, which is this one, to ground. Next, I'm going to place my 1 kilo ohm resistor to the base of the transistor, and the other lead goes to a blank spot on breadboard. Connect my push button switch. One lead of the switch will be connected to the resistor, and the other lead goes to the positive rail of the breadboard. Then I'm going to extend the collector of the transistor with a jumper wire, and I will connect my DC motor to the breadboard. This side of the DC motor goes to the collector of the transistor, and the other side goes to a blank spot. Then I will connect this blank spot to the positive rail of the breadboard. We are done with the setup of the circuit. I'm going to connect my 9V battery to the circuit, and let's test it. As I press the push button switch, the current flows through the resistor and through the transistor, which makes the transistor on. Since the DC motor is connected to the collector of the transistor, the DC motor is also turned on, along with the LED, which I soldered it to the terminals of the DC motor. I will do it one more time. Let's see. Let's make the experiment a little bit interesting. I'm going to demonstrate the signal of the circuit on oscilloscope. Here is my oscilloscope. I'm going to use channel 2, which is at 200 millivolts per division. Channel 1 is off. Next, I'm going to connect my oscilloscope probe to the circuit. This one goes to the ground, and the other probe goes to the positive rail of the breadboard. So right now I'm going to press the push button switch, and let's see how the signal of the circuit looks like. As you can see, we can observe too much noise and voltage spikes on oscilloscope. The signal is affected by these noises, and the solution to reduce these noises is to use capacitors. I'm going to place my 1000 microfarad capacitor to the circuit. The anode goes to the positive rail of the breadboard, and the cathode goes to the negative rail. And as I connect the capacitor, as you can see, the signal of the circuit is much better than before. Now let's see if I press the push button switch, let's see how the signal will look like. The signal is much smoother and better than before. The noises have been reduced, but still we can observe some voltage spikes which are not much greater than before. They have been reduced too.